So the question of is it all real numbers, sometimes you'll see this x to the 1/3 and you're like, oh my gosh, that's a problem because it's a radical. But remember, our odd indices are okay. Okay, so an odd index is never going to have a domain restriction. And so when you're looking at, okay, is it interior to the domain is all real numbers here. So you don't have a restriction on the domain because of the fact that it's an odd index. Okay. All right. So then we need to figure out where the first derivative is equal to 0 or does not exist. You can do whatever you want to do here. You could simplify first, or you could do the product rule. I'm personally going to simplify first because I feel like it's easier and it will demonstrate more than using the product rule. So if I simplify, and I can write it over here, the function is going to be distributing this x to the 1/3. So I have x to the first. Now, again, don't like overthink this. You're just going to add the exponents, right? The 1/3 plus 1. So the plus 1 is going to change into a 3/3. So that's going to give us x to the 4/3. Okay, so we'll have x to the 4/3 and then minus 4x to the 1/3. So that is just distributing. All right, so I'm just removing my parentheses. Now I'm going to differentiate. Okay, are there any questions about the simplification part? So I just add the 1/3 exponent plus 1. That's where I'm getting this 4/3 from removing the parentheses. Okay, now I'm going to take my derivative. So I'm going to bring down my exponent. I'm going to get a 4/3 x, and again, just kind of off to the side, 4/3 minus 1 changes into a 3/3. So that gives us a 1/3. So that's where this x to the 1/3 is going to come from. Then I'm going to multiply 1/3 times 4. That will give us 4/3 x. And then I'm going to take 1/3 minus 1. That will change into a 3/3. So I get negative 2/3. Okay. So that is my derivative. And I'm supposed to set this derivative equal to 0 or does not exist. And remember, we talked about how the f prime equal to 0 really amounts to setting the numerator equal to 0, and f prime does not exist amounts to setting the denominator equal to 0. Now, we have a little bit of a problem here. When you look at your derivative, you don't have a numerator and a denominator. You have two separate fractions. So what you want to do when this happens, and it will happen at some points, is you want to get one single fraction because you want to just be able to say, here's my numerator, here's my denominator. Most of the time, the best way to do that is to get rid of your negative exponents as soon as you possibly can. All right, so this negative exponent of negative 2/3, you don't want to keep that in the problem. You want to move that down into the denominator so that you can then a little easier to deal with. So this, I'm going to first move my negative exponent. Not going to worry about all the other problems. I'm just going to say, okay, let's move that negative exponent. Okay. Then, okay, so I've moved the x to the negative 2/3 down into the denominator to make it into a positive 2/3. Now, my goal is to get just one numerator and one denominator. Now, how am I going to take two separate fractions and combine them into one? I am going to need an LCD. So this fraction has 3. This fraction has 3 times x to the 2/3. So my LCD is going to be the bigger quantity of 3x to the 2/3. Okay, so least common, you actually pick the bigger quantity, so it all divides out. Okay, so if I make it my goal to get this as my LCD, the first fraction has the 3, but it is going to need the x to the 2/3. Okay, so that when I multiply it through, I'll have the 3 and I'll have the x to the 2/3. Now, the second fraction, we're in luck, has the 3 and it has the x to the 2/3. So before I say anything, I want you to take a minute and see if you can come up with a simplification step that would result after this.